All right, recording is rolling. It is Monday, August 26th. Right, so I do have a new seating charts put together, but we're not going to start this until tomorrow. Said one thing I want to do is change guys up about every 2 weeks. You guys get to meet lots of other students in class. So reason we're starting that tomorrow is because I do want you guys in your original group to stay because we got to do this this write-up scoring, right? This score the safety star write-up. And you guys are probably in your lab teams, probably, right? Be close enough, whatever it is. All right, after we score this, we're gonna go into linear motion. I'll go through the posters or just give you guys the thumbnail versions of these. Right, so on the back of, pull this up. Back of this one, right? All these red banners, we're gonna start going into today. All right, then all right, and kinematic formulas. Right now, there is testing going on in school tomorrow for 9th and 10th graders. I think there's a handful of 9th or 10th graders in here, so you probably know where you're testing. If you don't know, let me know. I have an Excel page to look at that up. All right, so any questions about what's going on? All right, so you guys remember back last week, back on Thursday, you guys did this lab. I know it's been a few days, so recap this real fast. You guys have these Hot Wheels cars going up down inclines. We're juggling all these variables, right? We've got the mass of the car, we've got the distance it goes, the time it takes to go that distance, how fast is it going at the end. Right, so what's the relationship among those variables, right? What equation are equations, right? Okay, so start from rest, okay? There are even maybe a couple of variables that we're not quite going to touch on yet, but maybe right? How about this angle, right? That we'll save that for a few weeks, right? But for you guys, I'll control that. I bet the car detected was in a gravity field, although that was also a control, the strength of the gravity field, because we can't really have different gravity fields. Right? Really hard. Right, and then back on Friday, you guys created graphs for these. You guys created graphs. Okay? Right, so and that uncover these relationships. Right, so now we got to score you guys' lab write-ups, right? So you guys remember that in AT, there's a pretty standard, so yeah, that's one before, right? There's a pretty standard lab write-up format, right? So there's some question that AP almost always gives to you, right? So I mean, some version of this, right? They'll usually target a question, right? And then they always want you to list your measuring tools, right? So I'm going to use this set of measuring tools. Then it's going to go procedure, right? They're really looking for 5 to 7 steps. Looks like I have 7 steps here, right? And so a brief description of the setup. So set up an incline, some angle, let the car roll down, boom, done. And then what did you use each measuring tool to measure, right? Oh, I used the scale to measure the mass, blah, blah. I used the meter stick to measure, right? So you go into analysis. A lot of times this is graphs, right? So that's what we did on Friday, right? I plot this axis versus this axis and look at the points, right? Might have to manipulate some variables, right? Like, oh, if I square the time and then I plot that on the graph, right? And then conclusion, make sure your conclusion answers your question, right? So whatever the target question was. Now, really, there were 4 questions floating around, right? 4 questions floating around, because that was the only way to handle all these different variables, right? So recap that too, right? So you guys were divided into these 4 groups, right? We're saying, how does mass affect the rolling time? What exactly is the relationship between distance and time? Time takes real different distances. Okay. There was a speed versus distance and speed versus time. Okay. All right, so what I want to do with you guys is on camera go over one of these 4. Right. So if you happen to have the spades, right, distance versus time, that's one I'm going to explicitly go over with everybody. Right. Then what I'm going to do is hand these scoring rubrics out and give you guys time to work with each other and score each other. Now, really score your own paper. Right, so you guys got the colored pencils, right, colored pencil on your desk. Here's how the scoring's going to work. This is going to be out of 12 points. Always make these out of 12 points because AP scores this out of 12 AP points. Okay, because whatever score you get on your own, like if you get 7 out of 12 points, that's pretty good for for the first lab. I created a grade column in Focus that is not part of your class grade, so it counts 0% towards your class grade. So if you get 7 out of 12, I'll put 7 in there, but it doesn't affect your class grade either way, right? It's just sitting there so you know, right? what I will put in points for is just that you completed it, you did it, and did all the graphs and did the write up, right? As long as you have all the parts that you did. Right? All right. So, any questions so far? You guys good? All right. So here, like I said, I'm gonna do this one with everybody. So go over one with these guys. Let's do spades, which is distance versus time. Right? Probably about a quarter of you guys have this one. And if you don't, then think tight because I'll get you the scoring rubrics in a minute. All right. So if you have spades, distance versus time, right, the question would be exactly this. What is the relationship between distance and time for a car to roll down an incline? Right? Of course, a constant mass for a car and a constant angle, constant gravity field. Right? You're keeping everything controlled except for you just focus on distance and time, that relationship. Okay. All right, so measuring tools. I would list all these. All right, so scale to measure the car or triple P balance to measure the car. You can do either one. Okay. Meter stick to measure the distance, a stopwatch trying to measure the time, a protractor so you can determine the angle. Right. I'm putting a point for each of these. I don't know if I wrote this from scratch, like today, I might write this a little different. I always try to make the points out to 12. Really, especially meter stick and stopwatch. That's, I think, the most important ones because those are the variables here. Like, if AP gave you this exact question and this exact prompt, they might give you a pass on scale to measure the mass of the car because they say, oh, don't worry, that's just constant. And also pass on the protractor. They say, oh, don't worry about the angle because the angle is just given to you, something like that, right? But you definitely need the meter stick and the stopwatch. Anyway, we're going to stick to the scoring convention because this is what I got for you guys, right? So you get a point for each of those, right? Because actually, like in reality, you really would want to have all four of those measuring tools because you want to check all those, even though a couple of those are controls. Okay. Okay. All right. So boom, 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 boom. There's 4 points out of 12. Again, these always add up to 12. This particular type 3 response question. Okay. All right. Now we're moving on to procedure. Okay. All right, so step 1, step an incline at a shallow angle above the horizontal for the toy car to roll down. All right, so brief description of the experimental setup. All right, now I just didn't throw a point on this one because I'm trying to get the points out to 12, but that would be an important step, right? I mean, there it is. I mean, just did one sentence. You described the whole setup. Boom, done. Right? Okay, so now everybody knows what you're doing. All right. Okay, now we're going to say, what tool are you using to measure what thing? Right, so use the protractor to measure the incline to the horizontal and record that number in degrees. Oh, look, I even got the unit here. Right? So a point for a mention of application of the protractor. Use the triple V balance to measure the mass of the car and record that value. I mean grams, because you guys did grams, right? We tend to stick to kilograms in this class because kilograms is going to be incorporated into more complex units, but for little labs labs like this where you have little tiny masses, grams is fine. Okay. Now again, those 2 points right there, those are controls, so that's all right. Okay. But especially these next couple steps here. With the meter stick, establish a 200 centimeter rolling distance for the car to roll down. Right, so 1 point for mention of the meter stick. Now, of course, that's not going to be controlled for the entire lab, but now we got a starting value, right? So now you specified a starting value. Okay, but meter stick is going to measure the distance. Okay. Step 5, release the car from rest, have the starting line at the top of the incline, use the stopwatch to measure how much time it took to reach the bottom of the incline. There's a point for a mention of the application of stopwatch. I'm going to use the stopwatch to measure time in seconds. How many seconds did it take? You guys get that? Right. So I'm using this tool to measure this thing, I'm using this tool to measure this thing. These two are actually critically important, right? The distance with the meter stick and the time with the stopwatch for this particular lab, if you have the spades. Okay. Okay. All right. So you guys good so far? Okay. Now step number 6. You guys see it says repeat this step 2 more times and take an average of the rolling time. Okay, guys, that is always, always, always a point on your AP exam. 1 point for mention of use of multiple trials to reduce random error. Okay, that's why when I gave you guys the table, right, see, again, it's trial, and I was doing like 3, and then, well, I helped you guys fill this out sort of together, right? We could do like 1, 2, 3, and then take an average. So you could have 1 column for time, and then you have like 3 different time recorded values. Then you have another column that says average time. You take those 3 and you average it. Right? This is really good experimental procedure anyway, right? Especially with the stopwatch, because the stopwatch is like the one that most, like, up for grabs, right? Like sometimes you're a little fast, sometimes you're a little slow with the stopwatch. So yeah, so yeah, multiple trials take an average to reduce random error, right? You guys got that? Right. That's always going to be a point on your AP exam to that particular step. Okay. And then step 7, change the rolling distance to 180 centimeters and repeat. Okay, steps 5 and 6. Right. So letting the car roll and measuring how much time. Do this for 5 different rolling distances. Okay, now we've established an independent variable. Maybe if I'd score this a little bit differently to make the points out to 12, this could have very well this could have been a scoring point, right? Maybe I'll go back and rescore this thing myself, but yeah. Yeah, so now you guys see how that establishes an independent variable, right? The fact that we're changing distances, right? And that pretty much covers the entire lab, right? If you had the spades, right? Like that's all you did, right? Okay, so we got all our measurements, we got our controls, we got independent, dependent variable, distance and time. Yeah, I mean, if you follow these steps, you got the whole thing, right? All right. All right. Now, okay, that was procedure. Okay, so here's what analysis looks like. Analysis. You guys remember, had you guys create some graphs? Let me see if I can dig this up real fast here. Here it is. Right. You guys remember, how do you guys create, okay, so if you plot straight distance versus time, guys, what shape was that for distance versus time? Yeah, parabola. Versus, okay, I think that was a class had kind of wonky data here. I think this one worked out a little better. Okay. Yeah, that was a parabola. Okay. And then we did this linearization trick, which is gonna come up over and over and over throughout the year, which is like how do you get the equation of a parabola? Yeah, it's a little tricky, but if you square, say, your horizontal axis variable, then now that will linearize, but it's not x versus t anymore, it's x versus t squared. But it's really easy to get an equation from this because you can just rise over run, go slope. Right? Although it's the same equation. You guys see the same equation applies to both these graphs, right? They look different shapes because they're on different sets of axes, right? All right, so that's just a reminder. We did that on Friday. And so, all right, how are we going to square that? Maybe something like this. Plot distance versus time for the car to roll down the incline, right? Because the shape of distance versus time, and then they're in some units, right? Distance could be in centimeters, time could be in seconds, for example. Right? Appears parabolic. Linearize the graph by graphing distance versus time squared. Right? So 1 point for graphing distance versus time squared, and then 1 point for specifying that there was a parabolic relationship between distance and time, something like that. Right? That could be implied as long as you have both graphs, which I think everybody does because we did them all together on Friday. So you should definitely get those 2 points because we did them all together. Right? Ooh, okay. I got a little detail here, which is maybe going to make more sense later on this week. Because that car was speeding up as it was going down the incline. Like it wasn't going constant speed because otherwise this graph wouldn't look the shapes they do, right? Like a constant speed graph, x versus t would look like a linear, but it doesn't. That's a parabola, right? So the car is definitely going faster and faster as it's going down the incline, right? The property is called acceleration, right? That's how fast it's speeding up. It's called acceleration, right? Well, at least for now it's going to be, right? It turns out that the slope of the linear graph, that x versus t squared, right, turns out to represent half the acceleration of the car. Right now, I wouldn't expect anybody to understand it, but that probably doesn't really make a lot of sense right now. Right? But maybe by the end of the week, it's starting to make sense. And then by the end of the year, but by the time you get the AP exam, like that should be something you would recognize by then. Right? Okay. And then conclusion. Remember, the original question was what's the relationship between x and t, between distance and time? Right? So we got to write something like that. So distance of the car roll down the incline is directly proportional to the square of the time rolling down the incline. Okay? That's exactly what this graph shows. Right? Distance is proportional to t squared. Right? Or you could have said, x. Okay, this also is x proportional to t squared. Right? X is proportional to t squared. Something like that. Some version of that. Right? AP cares about those types of proportional relationships like that. Right? If you came up with an equation, even better. Like if you wrote this equation and you said, okay, that applies for like a 5-degree incline angle, then that would work too. Right? If you're at x is 19 centimeter per second squared times t squared, boom, that's a great conclusion too. Okay, you guys good? All right, who's got question? All right, here's what I do. If you're watching this video at home, I'm about to pause this video. I'm gonna pass out these scoring rubrics, give you guys a few minutes to score your own papers. Again, like be honest with your own scoring, and regardless of how you do it, the grade book is just for like doing all the work and turning it in. Okay?